Now what about a potential due to a bunch of charges collected together? Well, potential due to a collection of point charges, say Q1, Q2, Q3, Q4, Q5, will just be given by adding the potentials together to get the total potential. So remember, potential was U over Q, electrical potential energy. The same principle will apply in this case. So for a collection of point charges, V will be equals to 1 over 4 pi epsilon naught Qn over Rn. Now on to an example. Calculate the potential at point P located at the center of the square if the point charges are as shown in the figure. Assume D is 1.3 and the charges are Q1, Q2, Q3, and Q4. Okay, so in this question, what it gives us is Q1, Q2, Q3, and Q4. And this is a square. Pretend it's a square, right? So this is Q1, Q2, Q3, and Q4. And it's saying find the potential at this point, right? And it gives me Q1 equals 12 nanocoulombs, Q2 equals minus 24 nanocoulombs, Q4 equals 17 nanocoulombs, and Q3 equals 31 nanocoulombs. And I have to find the potential at point P. Now what do I know? I know V will be equals to K sigma Qn over Rn. Okay? And since this is a square, it makes my life a little bit easier because I can calculate what this distance is, and that will be my R. So what in fact I'm going to end up doing is I'm going to need K Q1 over R1 plus Q2 over R2 plus Q3 over R3 plus Q4 over R4. And since all the R's are the same, I can pretty much erase all of those and take it common out. So I will have K over R. I'm just going to call it R because I called it capital R there. Q1 plus Q2 plus Q3 plus Q4, right? Once that one is done, I just need to find what R is. And finding R is easy because I'm going to use my Pythagorean theorem. It tells me that one side of this was 1.3 meters, did it? No, that's even easier. So if this is 1.3 meters, and I'm going to call this D, this is going to be D over 2, and this is also going to be D over 2. So R will be nothing else other than D over 2 squared plus D over 2 squared, using our handy-dandy Pythagorean theorems, right? Which means it is going to be 2D squared over 4 square root gets canceled, and I get D squared over 2, or D over 2 square root, okay? Plug that value in here, plug the values of Q's in here, and you get your potential, and that potential comes out to be 352 volts. Please note in here, you have to take into account that there is minus and plus signs here. So when you plug them in, make sure that you remember that the minus sign will actually go in here. So you're going to be able to use that minus sign. You have to use that minus sign in here.